Hi, Manuel.
Hi.
Our first guest, right?
First guest is about time, oder?
Yeah, it's about time. Do you think do you see yourself as an attentive person?
Yeah, I think so.
Today we'll talk about attention. Attention in humans, in AI, in your system, in your AI system, and how you overcome the computational efforts of attention, and then we will see if attention will overcome humanities.
Okay.
Yeah. So, please, your first question.
You always need to go that deep, Muda, to all the societal relevance. But it's actually Manuel's system. I'm convinced is something that people will talk about. But first, we should probably start with the cognitive side of things, right?
Yeah.
And acknowledge, okay, we humans, well, we are attentive beings. I guess all of us. For sure. And the question is really, what is this natural attention about? And there are numerous facets to it. Manu, you jump in if you want to, but the point is maybe the main point that is currently missing in AI systems to a large extent, and that is what we have implemented now and what is part in the human cognitive system, is that we don't see everything in our world all the time. We only see particular aspects of them.
Yeah.
And one of the main nice psychological tasks that came out, I think it's now 25 years ago or so, that these change blindness experiments came out.
The gorilla. It was the gorilla, right?
The gorilla is the inattentional blindness one. The gorilla is in our midst. That's also 25 years ago. But the first one was the change blindness experiment.
Change blindness, sorry.
Yeah. And change blindness basically shows images to you as a user. And then there is a little flicker, some patches or so that flicker. And there's one change. After that flicker, something has changed in the image. For example, the plant moves up 20 centimeters and then moves down again 20 centimeters, and you don't see it. If I would move the plant up 20 centimeters, of course everybody would see it, right? But if there's this weird splash while I move up the plant and then I look at it afterwards, I don't notice it, because my attention is more on us people, right, and on other details, and not so much on some fundamental background thing that is typically in our world stable.
Yeah. Unless if you are a farmer, so you will see the growth of that.
Yeah, exactly, right? Yeah. Depending on your task, depending on your priors, on your contextual framing that you are looking into.
This is like the frame problem.
This is again the frame problem. We keep coming up with it every time. But that's one important part of attention.
Yeah.
And Manu, you have kind of implemented this now, right? Exactly. Or what would you mention from the psychological side? What's important for you on that attention side still?
Yeah, so for me, what's most important is that it's usually about objects in our attention. So we don't perceive the whole image, everything at once, but we rather look at particular objects that are interesting to us. So if I drink, then the cup is interesting.
Yeah, the entities,
And that is the focus that we have. We segment these entities in our minds, and we relate them spatially to the background still, but what's the focus are the entities. No?
Yeah. Let's first deconstruct the attention in humans. What does it mean, attention? Why we have attention? What are the mechanisms in our mind that result the attention?
Yeah, so we cannot focus on everything, basically. So our brain has a limited capacity. We cannot perceive every book in the store while talking to you guys. So we need to have somehow a focus, what is relevant. And this focus in our brain is solved by attending to specific objects that are currently relevant. And that in AI system is mostly not the case today.
Yeah.
Essentially, we save resources, right? Yeah. The point is, we have limited cognitive capacities, although we are humans and we believe we are so super smart and so forth, right?
Yeah,
the smartness is limited. We all know, right? Any standard computer can play better chess than we can now, right? Even Go, we have learned from the computer how to play it better now, interestingly enough, very important to notice also. First really innovative, clear example of an innovation that comes from the computer and teaches humans how to do it better. And this limited capacity makes us the need to save energy or do our computations maximally efficiently. And one aspect of this is basically not to encode everything in the world, but only try to encode that in the world that's currently relevant.
This answer leads me to the next questions. Okay, we have this capacity that we want to reduce the energy that we are consuming. But what are the elements that governing these mechanism of attention so we can keep our capacity on...
So how do we focus on something, you mean?
Yeah.
How do we attend towards something?
Yeah, like...
Yeah, I think it's the context, so what you currently want to do. So that focuses your attention on, if you're making a cup of tea or something, then you go in the room, look for the water cooker and so forth.
Exactly. So you have the foci, right? On the one hand side, the task-specific foci, and the point then is really though that this focus that you currently have goes all the way down to the modalities, right? To the sensory level nearly, and you focus your V1, your primary visual cortex, your first analysis of the visual stream of information onto that sub-area and onto those features that you're currently interested in.
I will open the door for you, Martin, and you go and explain everything. Yeah. Let's speak on attention from the perspective of the triangle of the framework of attentional selections. Top-down, bottom-up, and
right.
history biases. So like, could you please explain attention from this perspective to our audience so they can understand how they are attentive?
So generally, right, one has to distinguish between two types of attention. There is the attention that is bottom-up, sometimes called attention, that comes from the sensors itself.
The environment?
From the environment itself, via our sensors, right? If I suddenly move crazy, right, everybody grabs their attention, right? And or suddenly this cup falls over or so, it would grab attention because there's a surprising thing happening that is not expected, that comes from the sensors, that is signaled by the sensors. This is bottom-up attention, dragging our mind's attention to that thing that suddenly happened and that I haven't expected.
Sensation-based. So
it's basically a sensation bottom-up from the sensors up.
What we see, what we feel, what we hear, what we smell.
Exactly. It can be any sensor. It doesn't really matter, right? And it seems that our mind monitors all the senses that we have all the time and has basically something like an expectation prior, like an assumption what signals should come in from the sensors. And usually the signals just come in the range that I expected them to come in, and I'm fine. I don't get pulled my attention to it, right? But if I suddenly do this, right, then what's it doing, right? And then your attention is dragged to that sensory stimulation. Meanwhile, there is the top-down attention. That's our task-oriented, what Manuel just also talked about, right? It's our task-oriented attention. What are we currently thinking about? What do we want to do? Therefore, what parts of the world do I need to attend to? To you guys that try to think along, and I hope you understand me, the audience I have in my mind a little bit, right? This cup that I can drink a sip of coffee to get some more energy, whatnot, right? This task-oriented top-down attention. And this top-down attention, that is now the gorilla experiment, right? That is super famous basically because it's so nicely...
Yeah, we will go there later. But like, let's give an example of driving a car. and how both kind of attentions could work together or fight against each other, and how we can enhance our attention regarding to those two kind.
Yeah, yeah. You want to?
Yeah,
Yeah,
sure.
just-
So for example, if your traffic light suddenly turns red, that's the external attention. But also where you want to go, that's so sort of your internal. You look for maybe on your phone the navigation or so that drags your attention to that or so.
Which is then the problem, right? That's why one shouldn't use a cell phone basically in the car, right? Because this cell phone, if you have suddenly an engaging conversation on your cell phone, that drags you into this cell phone and this person somewhere totally else, remotely, right? It drags your attention into something that is not street road control relevant. And because we have limited capacity, our attention on the road relevant stuff can drop, unfortunately, to a dangerous level, right?
Let's
and then it
deconstruct
becomes dangerous.
the scene of the talking driver. We have a goal-oriented attention from the top down. It's about like, I want to go to this university to
Sure, you just follow the road, say, right? For that matter.
So
right?
your attention is focused on everything to reach your office. Then there are two kinds of bottom-up attention. One is the environment of the driving, cars, lights, noises, constructions everywhere.
And if somebody breaks in front of you, right, and comes dangerously close, you realize, oh, right, and your attention is dragged onto the road.
So, like, in this way, you need to decrease the speed. You know that increasing the speed is better to reach faster to your goal, but you have to take out this sensory income because you don't want to have a crash. Then you like manipulate. So this is in this way they are working together to reach your goal.
Absolutely.
But the other kind of the bottom-up attention is the calling, the person who is calling, and this person is not helping you to reach your goal. So this is contradicting your own real attention that you want to manipulate between the bottom-up and top-down to reach your goal safely.
That's it.
So don't talk. You can talk to your friend or family or wife in the office, and keep the battle only between only two parties of the attention, not three. Otherwise, the top-down will overcome, and then you will have a crash.
The more the conversation drags you into a different context, right, that is not road-related, the more dangerous it gets, basically. Right? And you cannot control this because, I mean, you get engaged in this conversation that is far from about a different context, possibly even about a different spatial context, social spatial context maybe, or something like this even. And that drags all the attention away from this car spatial context, and then it gets, then it's dangerous.
And then we have a limited capacity of dealing with
the
sensories that we are having. So like try like intentionally to reduce the sensors that are coming to you by avoiding any
distraction like that.
Exactly. Definitely. And then like because of that, like okay, don't use your phone texting like while driving. Just like and like so this is attention, and this is how we can like take care of it, like trying to manipulate the environment in a way that we can just keep focusing and then like there is an idea I want you to also describe, or Manuel, like the idea of the sudden strong stimulus from the environment and how it like drags all our attention to it and kill any goal that we want to achieve.
The bottom-up, strong bottom-up attention.
And how it affects even the system of LLMs, for example, like not LLMs, any AI system. So we can now shift to AI systems.
So Yeah, but maybe in the car example, if the person before you saw something on the road that you didn't saw and then brakes suddenly. So this is, and then the cars start approaching you, or the distance gets shorter really fast. That really drags your attention away from everything you're currently thinking about. Maybe your mind was wandering or so, but then you focus really on that and just hitting the brakes.
Mm-hmm. Let's take it to AI. Mm-hmm. If there is an AI system of face recognition, mm-hmm. how could an environmental stimulus affect this attention? What is the attention of AI? Let's start with this.
Well, the standard ones, not so much, right? Yeah. But you can say,
Yeah, so I mean the standard notion of attention is quite different from what we humans do.
Yeah.
So in AI, attention usually means that you have some sort of query and you have sort of abstract keys and values, and then you attend to that. And this is usually over the whole image. So you have your camera, and your camera sees the whole street, everything. Also maybe the I don't know, houses on the street and the trees and so forth. And they take up much more space than the road and the cars in front of you. And so the attention of the network then really has to pick out what's relevant. So it has a sort of query, what it wants to do. Also maybe driving or so, but it has to really then pick out the individual objects from the whole image, sort of.
That's how it's kind of standard segmentation mm-hmm. systems work right now, right? Yeah. They analyze the whole scene, the whole RGB image or whatever, mm-hmm. color matrix essentially, right? And processing the whole scene first, and then via query key value principles mm-hmm. essentially relate information in the image to each other in the vision transformer essentially, and then you can add at some level some form of query that basically says, I want you to segment the mug or something mm-hmm. like that, right?
Yeah, but like, what is the AI attention? How is the AI system is attentive? What does it mean? Do they have the same attention of humans? When we say this is like...
I mean, the bottom-up attention, this what we've talked about, mm-hmm. this surprising stimuli, right? A surprise is in the standard AI deep learning pipelines not really represented, right? No, it's not encoded. There's no real prediction that I want to see or expect to see this, and then the stimulus comes in and it's very different from what I expected, and then it rises to attention. This is what predictive coding systems do, mm-hmm. but standard deep learning vision systems not.
Yeah.
No.
So they have an human-like attention, not a real attention, the AI systems.
Or they don't have a human-like attention, right? They don't have this bottom-up like attention, right? But they do have a kind of a top-down kind of attention mm-hmm. mechanism is there. With what Manuel just tried to explain, this query key value principle, mm-hmm. where the query is kind of your task, right? Or your focus that you want that is imposed to you.
Mm-hmm. What are the cons of the human attentions? Let's talk about an intentional blindness, maybe, or like also mm-hmm. change blindness. And mm-hmm. what are the cons of the AI attentions if there is an attention in general, right?
And maybe to contrast them, the AI attention really can attend to everything in the image, so it don't have the bottleneck that we humans have. But that's also maybe the shortfall, so it really has to attend to everything and has to learn to pick out the things that are relevant. And this learning takes a huge amount of data. That's why those models are so data hungry.
Mm-hmm. Exactly right. The point is really that the current deep learners, they analyze everything in the image, and we don't. As a result, the deep learners that analyze everything in the image, they need to be much larger, they consume more energy, they need to process more data to learn even this stuff, right? Because they just need to analyze everything, and then I evaluate it to still segment this cup, right? And that is inefficient.
Yeah. So like the problems. The cons of the AI attention is they don't have our cons in attention.
Yes, exactly. You can say so, right?
Could you please explain the blindness?
So
attentional blindness.
right, so if you have then inattentional blindness, then and that an AI system would probably not have this problem if it processes the whole image.
What is
Right,
inattentional?
inattentional blindness is the gorilla experiment. Just Google gorilla experiment or ask your favorite LLM if you want. It's so famous that everybody will explain everything. All the systems will know about it and explain it to you. But essentially, the point is your task is to follow a team of basketball players around, and they pass a basketball to each other. And your task is to, for example, count the number of passes. And while you're happily counting this number of passes, a person in a gorilla costume walks through the image, even like pounces its breast briefly or so, in a funny gorilla-like way, right? And more than 50% of the people don't see it. They don't see the gorilla, totally. They don't notice the gorilla at all. They
Gorilla? No gorilla.
it's right, because you're so busy doing your task, you don't see the gorilla. Even if the team that you count has black jerseys on and the gorilla is also in black, even then you don't necessarily see it a little bit more often than when you have to count the team with the white jerseys, but still you don't necessarily see it, right? This means much more than segmenting one individual object or focusing on one individual object, but you track a team of players essentially over time with the ball, and you focus on this team of players and the balls, and everything else for your mind is background, so to say, or is not relevant.
So AI systems don't have the gorilla problem, the inattentional blindness.
The AI systems will not have the gorilla problem in their current implementation.
Because we don't have the frame problem, they have the frame problem.
Yes, in the sense, yes,
It's
right?
like this.
I mean, it is depending on the capacity, right? If you have infinite amounts of energy in this world, which we don't, then you can just program AI systems that use infinite amounts of energy and build power plants to run them or so. If you really want to go down that way, I'm not sure if this is a good idea, right? The benefit of not doing this is to build focused artificial attention systems that process much less of the image because they just have the task to track, for example, this cup. But the downside of this is that they might overlook something that is relevant after all.
I have a nice question. In scale of 10. I will just like put an ADHD person in 2 of attention.
Okay.
The ADHD, there's no attention at all. They are,
No, they also attend, but the attention switches a lot, right?
Yeah. So 2. Yeah. Where like 2 of you? I need the answer from 2 of you.
And what is 10?
I don't know. You will like tell me. Where is a human? A human being.
Yeah.
And where is AI and where is AGI?
Oh, it's difficult. To put it on one scale, what would be 10?
I would say normal human, the average is 8 maybe, and then you have people that are super focused or so.
With ecstasy.
I don't know. Yeah. It's difficult how you would.
I mean, if you would say, if you would say 1 is like processing everything all the time, and 10 is really able to focus on one particular task and ignore everything else. So you have a strong gorilla problem with 10, but you're super good in processing one particular task.
Keep focusing keep focusing and manipulate the environment so you don't get hurt. So this is like the ultimate goal of a superhuman being. You can focus and survive.
But I think the ultimate goal is, right, you don't want to be on 10 and you don't want to be on 1 either, right? So you want to be on 5 or something like this, right? Or 7 or so, right? Because you indeed want to save energy and do it efficiently, but you also want to track the rest, right? Such that very significant changes that you should really become aware of, you do become aware of, right? And if you're too focused on one thing, then you might indeed overlook that there's something really dangerous coming up, right? Yeah. That's the car situation, right? Yeah. Where you concentrate too much on something, then you create an accident because you didn't pay attention.
Maybe a multitasker person.
It's
like
a multi
7 tasks.
Right. Yeah. I mean, it's an AI system with more capacity, right? That would pursue multiple tasks all the time. For example, having a monitoring system that monitors the whole image, analyzes the whole image, but not to a deep extent, right? But just to, okay, is there something surprising, strange happening and so forth, right? There could be a whole monitor, but then additionally have an additional independent systems basically that do something like what Manuel's system do, for example, that really track one thing in very dedicated and exact manner. That's probably the best, probably a good compromise, or could really work as an AI system, and that would be superhuman capability basically, right? Because it has then parallel contexts that it keeps and that it processes, and that's what our mind cannot do.
Yeah. If we keep the car example, you could envision an AI system that sort of tracks all the participants, the people, the cars and everything, and then also has this greater context of looking at the whole image, but sort of with less compute and looking for something unexpected, but have a higher threshold there. And this would be superhuman. We cannot focus on everything, every person and every car and so forth, but an AI system that has focused capacity or focused processing, that could be actually quite efficient if it only focuses on individual, not all objects, but the important ones.
There is a myth or like a stereotype about like women are multitaskers and men are not. Do you believe in this, or it's scientifically not proven? No answer, no. No, there's no any study about this topic or this myth?
I'm not aware of it right now. I would have to look it up. I mean, surely there can be differences detected. Multitasking is probably something that women are a little bit better in.
It's a human. Like it's
on average.
Like every human has his own, or her own, or their own capacity of how to multitask or not.
Everybody has their own capacity for sure. I mean, this is a very surely a very individual trait of each individual human, how we tend to distribute our attention, how much we are able to keep focus on one particular entity. I was sometimes made fun of during my PhD time, right? So that I was so focused in programming something that some of my office mates could like stand next and wave and stuff, and I wouldn't notice it. So.
You are still the same with the ARC challenge.
Yes. I still have that trait. Yes.
So now we will go to the main questions. We are like I have been hearing the whole recording this episode like manual project. What are you working now on?
So I'm working on a new AI system that really focuses on individual objects. So basically we don't process the whole image and instead focus on individual objects, and therefore we sort of allocate more resources to that small objects. So if the traditional AI systems process the whole image and you have a very small object, then this is sort of 0.1 of the total compute, but we can focus 100% of our compute on that small object if it's deemed relevant.
So you are working on attention, it's not a random topic.
Yeah, sure.
So could you please explain why like Martin said it's gonna be public and everyone should hear about it? Why? Because you are his student, or?
Yeah, sure.
Also.
Because we can save a lot of energy and compute while doing this.
How? Explain it without any academic terms or like AI terms.
Yeah, it's basically the only reason is because we don't process the whole image. we can focus on these small objects.
Okay. How you did it, or you don't want to talk about it yet?
No, we can talk about it.
How you turn the focus of the AI system, of your AI system, from the whole scene to this car?
Well, we would have to talk a little bit of how AIs process images. So basically, traditional systems grid the image into smaller patches and then process all these patches. And therefore, you are sort of limited. The smaller the patches, the closer you look at individual stuff, but your compute explodes basically. And what we are doing is we focus our compute onto only this mug, and then we can have much smaller image patches only at this mug, and therefore processes in much higher detail if we were to look at the whole image and then have here coarser grids.
So it chooses only the pixels of the mug.
Yeah.
And like exclude everything, all other pixels, and just process this. But why it includes the mug? It's like a prompt. That
it's a prompt.
Yeah, it's a prompt.
Yeah, so you will ask as a user your system to do this.
Yeah, so basically your input prompt is sort of a spotlight and you can control the size of it. So you say, okay, look here, basically, and then you see the mug and a little bit of the surrounding and so. And you could also look broader, so look at the table, for example.
And why it's better? I mean, sell it to me.
Yeah, it's...
And don't tell me computationally less effort. Like, no, I need why. What is inside it? Less parameters? More?
1,000 times less parameters.
Why? How?
Because it just processes dedicatedly that part of the image that is part of the object and analyzes essentially where the edges of the image implicitly and is trained to do so and is learning this really well.
And did you like invented some kind of new algorithm that can work faster also, or no? It's just about like cutting.
Yeah, so the main benefit or the main compute savings really come from this focused processing.
Okay.
The other parts are pretty standard for computational or deep learning terms. There are of course some differences, but they are pretty much technical.
Give me applications.
So sort of like the autonomous driving is maybe the easiest to think about. You can have these focused attention on individual passengers or cars on the road and so forth, pedestrians,
But like in this autopilot, you need like a pilot for the program to autopilot the car. You need to like tell.
So it would be the vision side of a whole driving system. So you would have these different components, these different spotlights that look at the different objects, track them over time, and then
automatic it will be.
It would be.
So the system will recognize the objects and analyze it, and then like list it like this is important to.
Yeah.
So right now we give it the app that's online now, right? That we will give the link, right? That's basically you still have to say, okay, this is your region of interest, and now segment this object to me, right? But you can in principle have this region of interest automatized, that it samples region of interest and then starts to grab onto objects, and you can kind of read out if it has an object now or not, basically, and then it can track this over time. And so this will be much more efficient than the other segment.
So he started with imagined application. Now, please tell me about the real application. How can I use it?
So now if it's of course just a sort of research demo, but the future application would be some sort of this multi-object tracking system where you track individual objects that are relevant for your current task, and then you can specifically reason over those objects.
I have an application. Like, like when the football game and there is a camera and the camera tracking the ball.
Definitely.
And then you can just the prompt is like just focus on this ball, and then the camera will track it without a high consuming of the battery.
Yeah, that would be a
This is a good-
theoretically application.
Yeah, so like they will save a lot of batteries and charging and a lot of equipments. Yeah.
You can't even make the cameras automatic, that they follow players
Yeah,
around
yeah,
or so, right? And
Yeah. So you just choose.
or you
like-
can also do like, you know, if you have a wide high resolution camera watching the whole game, which they already do right now, but you could do it much more efficiently with Manuel system, that it basically tracks all the players and puts it digitally immediately, okay, where was each player on at any point in time, what did he do, what did he do, and so forth.
Yeah, and by the way, now there is like an AI system, or I don't know if it's AI or no, like for fiction series and fiction like cinema, and there is like a track and the camera, and then like it's chariot, and like then you tell the system to walk, to like move from here to here, and then the camera will move this. But you don't need to choose point A and point B. You choose a person, track the face of the actor, and move with him or with
Definitely, you could do that too, yeah.
Yeah.
But for simple applications, you know, you can also upload your image of your favorite cat, right? And then just mark the cat, and you will get the cat out in no time and very cheap, and it's and you have your cat and can do whatever you want with it.
Yeah, and or if there's like if you have like a very crazy boyfriend or girlfriend, you just like, if you have a photo with someone you don't need in the photo, you just like take it out.
Yeah, but then, okay, you still need to then define what's in the background there, right? So that's the filling in is not directly part of that.
So like maybe you are gonna be rich in the future.
Well, we are researchers from the outset right now, but we'll see. Maybe we should.
In USA, for sure, if you would be like in the USA, you would be like rich, but like
we can also do it in Europe.
Yeah.
Hopefully, maybe for the ARC challenges
Exactly.
in the future. Okay, I have one last question about attention. Do you think, like this for you both, an attentive robotic system will overcome humanity and we will be slaves and enslaved?
Always the big question in the end.
Yeah, I hope not.
Yeah, I hope not. I mean, we all hope not, right? I think there is, we're developing, this world develops clearly, if it's from us, if it's from Meta, if it's from DeepMind, whoever. We're developing systems right now that become superhuman in their capacities, in their abilities. This world is steering in this direction. There is clearly no barrier that will stop this, in my opinion. I also have talked to many neuroscientists about this or so. There's nothing that we know about in our brain that could not be modeled in the computer in principle. So it's everything looks like that we will have to face such systems, and we will have to do the best of it, right? The systems can show us new ways to solve world problems. The systems can do policy recommendations and so forth that no politician has even realized that this would be possible and would possibly work. It can argue in favor of things that could profit many. It could also argue about the downsides of it and the pros and cons about things, right? All of this should make us hopeful that these AI systems are useful and are good for our world. But meanwhile, it is clear that there is so many influencers in this world, high-level, highly powerful influencers. Let's not talk names maybe today, but and it's not in their interest to save the world problems. In their interest is to keep making money with how the world currently works, and this is something that this world faces, and we have to deal with and think about how we can do it better.
I have one more comment. Like, It's a question also, like, you know, like how the mother would talk with her son or daughter or whatever, like focus and study well, stop like playing on your phone, smartphone or something. Would you think that we will have this robot when we will say like focus on cleaning, don't look to the window to that? Do you think we will have this?
Well, I don't think so. I mean, because the robot will have its tasks and it will have its general objective, right? I think we are far away from the emotional Douglas Adams depressed door or something, right? There's no reason to put this into a robotic system, and I think we more or less know how one would put something like this in a robotic system. So I don't think we will face
we're not
this,
gonna hear this sentence like, "Oh, my robot is driving me crazy," because
or he's getting depressed, right? Because I doubt it, but who knows?
It's gonna be fun. It's gonna be okay. Thank you very much for being our first guest.
Thank you.
Well, I hope you will be rich soon with your own
would be nice.
system. Please don't
a little bit.
Don't forget us. We helped you a little bit. Thank you, Martin. You are also a presenter. It's not me, but like thank me also.
Thank you, Murato, as usual, to lead through the sessions, and I hope everybody enjoyed it.
Yeah, and
right?
like they have been attentive the whole episode and not focusing on something else.
Maybe they ran it on 1.5 speed, so it was easier.
Exactly. Yeah,
Take care.